Get your free copy of the complete tutorial at www.teachucomp.com/free.
Access is a relational database application. So what does the term relational mean, and how is this important? The term relational describes the method used for storing data within the database tables. However, it may be easier to understand the relational model of data storage by contrasting it with another method of storage that you may be more familiar with, the flat file method. Many types of databases are stored in large flat files. For example, assume that we want to create a database file that stores our company's customer information. We would begin by listing the different attributes of the customer which we wish to record. We may want to record information like the customer's first name, the last name, the company for which they work, and other relevant pieces of information. Perhaps you could create a list in an application like Excel, where you create columns for each piece of information that you wish to record. We can then list each customer's information in the rows beneath the columns, creating what is essentially a table. It may look like the example shown here. And for many types of databases or lists, the structure shown would work well. This is a flat file list or database. What we're doing in this database is recording a single piece of information, like first name, last name, or address, about a single entity, in this case, a customer. Now, the reason that this type of data structure works well in the example shown is because for each entity, the customer, we are only recording information that has a one-to-one relationship with this entity. So, what do we mean when we refer to this one-to-one relationship between the entity, the customer, and the data we're recording, first name, last name? What this means is that for each entity, the customer, we are only recording information about that entity of which there would only be one answer. So, for example, each customer would only have one first name and one last name. They would work for only one company. So the term one-to-one refers to the relationship between the entities in the table, in this case the customers, and the data being collected about the entities, the fields. Because for each customer, there's only one possible piece of data to record in the column, we say that the relationship between the data and the entity is one-to-one. If this is the type of database that you're trying to create, simple lists in Excel, which create flat file databases, will work well. The problem occurs when you try to use a flat file approach to model something more complex, like sales. For example, let's say we wanted to expand our example flat file database. Let's say that now, in addition to the information being collected already, we also want to record each purchase made by a customer. So first we would start by listing what it is about each sale that we wish to record. Keeping our example simple, let's say that we decide to record the sale date, the items purchased, the quantity of items purchased, and the amount paid for each item. So we may decide to add the following columns to our data structure. This may appear to work at first glance. However, you will immediately begin to encounter problems. To begin with, every time the customer makes a purchase, you would have to re-enter all of the first name, last name, company, address, city, state, and zip information just to be able to put in the sale date, the item purchased, the quantity, and the amount. This alone is irritating enough. But you'll soon run into another problem. What do we do when a customer purchases multiple items in a single sales transaction? One solution often proposed at this point is to simply enter another row along with all of the redundant information that that row contains, like the customer's name, their company, their address, and do that for each item purchased in the transaction. Now that's not an elegant solution, and it will inevitably waste both the time and effort of the person who performs the data entry, since the growth in the data table will then go downward very rapidly, one row for each item purchased. Another solution often proposed is to create additional columns like item 1, item 2, item 3, quantity 1, quantity 2, quantity 3, amount 1, amount 2, amount 3, instead of having to enter additional rows of information. And while this might seem like a good alternate solution, what will we do when someone purchases 100 items? Will we really create a set of 3 columns, item, quantity, and amount, for each item, producing a database table over 300 columns across? Would we simply leave them blank if the person orders only one item, wasting valuable storage space? In this solution, we're simply substituting columnar growth across for the vertical growth down, so that's not really an elegant solution either. So why are we having a problem now, when we didn't earlier? The answer is that we're no longer trying to model a one-to-one data relationship. Recording sales information is simply more complex than recording the customer information. What we're trying to record now is what is referred to as a one-to-many relationship. Basically, for each entity that we were recording, the customer, we're now trying to record data which can occur more than once per customer. The items ordered by a customer, for example. We must allow for the fact that in a sale, each customer might order many items. Each customer might have many sales. So the relationship between customers and sales, or items purchased, is a one-to-many relationship. When we find that we're trying to model a one-to-many relationship, it is then that we must abandon the flat file method of data storage, where we try to place all of the information that we want to record into a single table, and turn to the relational model of data storage for the solution.
Like what you see? Pick up your free copy of the complete tutorial at www.teachucomp.com/free.